In this question, we're asked to divide these two rational expressions. In order to do that, we want to first turn it into a multiplication problem. Because when we divide two fractions, we're really multiplying by the second fraction's reciprocal. So in this case, we're going to be able to rewrite this as 5x squared plus 25x plus 20 over 10x plus 20. That part has stayed the same because you keep the first fraction, then you change to multiplication, and then you flip the second fraction. So the second fraction, we're going to take what was on the bottom and put it on the top. And what was on the top now goes on the bottom. Now that we have turned this into a multiplication problem, we want to factor all of the pieces. So when we're looking at each of these pieces, we're going to factor the GCF out first, if possible. So for example, on this first piece, 5x squared plus 25x plus 20, I know that I can pull a 5 out of all of those terms. Okay, 5x squared divided by 5 is x squared. 25x divided by 5 is 5x. And 20 divided by 5 is 4. The other thing that I can do here is continue factoring my part that's still in parentheses here. What two numbers multiply to 4 but add to 5? So again, multiply to 4, add to 5. Well, the two numbers that do that are 4 and 1. Remember, we can use that shortcut strategy because we have a leading coefficient of 1 in front of the x squared. If it was anything but 1 there, then you would need to do the AC method. Okay, so x plus 4 times x plus 1, and then we have the 5. So we have 5 times x plus 4 times x plus 1 on the top of that fraction. On the bottom of that fraction, notice that we have 10x plus 20, which is going to be also factorable by 5. So I can pull a 5 out, but I can actually pull something bigger than that. So don't be tempted to just keep the number that you pulled out on the top. I can pull a 10 out of both terms in this case. That's the GCF. So that leaves me with x plus 2 inside the parentheses. Now let's go over to our other fraction. X squared minus x minus 6 is the top of the fraction. So we want to find two numbers that multiply to negative 6, but then add to positive 1. So this might be a little harder to see automatically just because of the way that 6 works. So think about what multiplies to 6. We could have 1 and 6, or we could have 2 and 3. So since we want it to multiply to negative 6, one of those has to be positive, one has to be negative. So in this case, we're going to pick negative 3 and positive 2 as our two numbers, because negative 3 and 2 add up to negative 1. So that is why we split that up there. And then 4x plus 16, we can factor the GCF out of this one as well. I can pull a 4 out of both terms. And that leaves me with x plus 4 inside of my parentheses. Now, I can cancel some things out, which is great. So looking at this, I can say, okay, what is the same on the top and the bottom of the fractions? Well, I can take this x plus 4 and cancel it with this x plus 4. I can take this x plus 2 and cancel it with this x plus 2. I don't have any x plus 1 or x minus 3 in the bottom of the fraction, so I can't cancel those out, but I can simplify the 5. The 5 and the 10 can simplify and become 1/2. All right, so what does that give us all together? Well, on the top, I still have 1, x plus 1, and x minus 3. So I can write that as x plus 1, x minus 3. What do I still have left on the bottom? Well, on the bottom, I still have 2 and 4. 2 times 4 will give us 8. So altogether, our final answer is x plus 1 times x minus 3 all over 8.